This is the video to go along with the index laws homework, so make sure you have that out in front of you right now so you're able to take notes as you're watching this video. So first, a quick reminder of index laws from GCSE. Remember that if the bases are the same and we're multiplying, we can add the powers. So a plus b, so x to the power a multiplied by x to the power b is the same thing as x to the power a plus b. If we're dividing, then we subtract the powers. And then finally, remember that x to the power a all to the power b is the same thing as x to the power a multiplied by b, so ab. A few examples of using those. 2 to the power 3 multiplied by 2 to the power 5 is the same thing as 2 to the power 3 plus 5, which is 2 to the power 8. I could go the other way. Here I've got 3 to the power x plus 1. The powers are being added, so I could think of this as being 3 to the power x multiplied by 3 to the power 1. Or, switching these around, I could think of it as being 3 to the power 1 times 3 to the power x, or just 3 times 3 to the power x. If I've got 5 to the power 3x divided by, remember a fraction just means divided by, 5 to the power 3x divided by 5 squared, I can subtract those powers to get 5 to the power 3x minus 2. I could go the other way. If I've got 2 to the power y minus 1, I could, if I wanted to, think of that as being 2 to the power y divided by 2 to the power 1, or just 1/2 of 2 to the power y, if I prefer. X squared all to the power 3 is the same thing as x to the power 2 times 3, which is 6. If I had 4 to the power 2x, I could think of that, if I wanted to, as being 4 to the power 2 all to the power x, which would be 16 to the power x. Alternatively, because it doesn't matter which way round we multiply, I could swap the 2 and the x around and say that this is the same thing as 4 to the power x squared, if I wanted to. 25 to the power y. We'll see shortly that it could be useful to think of that 25 as 5 squared. So I could replace the 25 with 5 squared, and then using the index law I could, if I wanted to, write that as 5 to the power 2y. So 25 to the power y is the same thing as 5 to the power 2y. What about fractional powers? X to the power of 1/2 means the square root of x. X to the power of 1/3 means the cube root of x. X to the power 2/3, or the third part, means the cube root, and the squared part on the top means for me to be squaring that. So I cube root first, and then square afterwards. You could, if you wanted to, do it the other way around. You could square first, and then cube root afterwards. but most of the time it's easier to cube root first to make the number smaller and then square afterwards. It doesn't particularly matter though. So if I had 2 root x and I wanted to write that in index form, I can think of that as being 2 times root x, and as we just saw, the root x is the same thing as x to the power of a half, so I would have 2 times x to the power of 1/2. Next, I've got the cube root of x over 2. So the cube root of x, I know I can rewrite that as x to the power of 1/3 divided by 2. So I could write that as a half x to the power of 1/3. Dividing by 2 is the same thing as timesing by a half. Next, I've got root x times cube root x. Well, the root x, I know that's the same thing as x to the power of 1/2, so I could replace that with x to the power of a half. And then the cube root of x, I know I could replace that with x to the power of 1/3. And then multiplying those together means to add the powers together. To add those powers together, I need a common denominator. A half is the same thing as 3 out of 6. 1/3 is the same thing as 2 out of 6. Adding those powers together gives me x to the power 5 out of 6. Negative powers. X to the power minus 1 means I have 1 over x to the power 1. We don't really need that power 1 on the bottom there. You can just write 1 over x. The negative has moved the x to the denominator. X to the power minus 2 means I have 1 over x squared. Again, the negative has moved the squared to the denominator. X to the power of minus 1/2, the minus moves it to the denominator, and we saw just a moment ago that a power of a half is the same thing as square root. So x to the power of minus 1/2 is 1 over the square root of x. So 2 over x, I can think of that as being the same thing as 2 times 1 over x, which is the same thing as 2x to the power minus 1. One over 3x squared. I can think of 1 over 3x squared as being 1/3 multiplied by 1 over x squared, because the 1 times the 1 is the 1, and the 3 times the x squared gives the 3x squared. The 1 over the x squared, we saw a moment ago, I can think of that as being x to the power minus 2. So I've got 1/3 x to the power minus 2. Notice in these 2 examples we've just done, the 2 on the top here stayed on the top. The 3 on the bottom here stayed on the bottom. We tend not to move the constant numbers, we only move the powers of x. Next example, we've got 10 over 2 root x. So, notice right at the beginning that the 10 divided by 2, we can simplify that a little bit. We can cancel that. Divide top and bottom by 2, we get 5 over root x. Which is the same thing as 5 times 1 over root x, The root means we've got a power of 1/2, and it's on the denominator, so it's going to be x to the power of minus 1/2. So 5x to the power of minus 1/2. Let's make it a bit trickier by looking at these 4 examples. So we've got root x times x plus 2. I'm going to rewrite this root x as x to the power of 1/2. And now I'm going to expand these brackets. So I'm going to have the x to the power of 1/2 multiplied by x. Now that x has got a little power 1 there on it. We just don't bother writing the 1. But by writing it like that now, I can see that I need to add the powers when I'm multiplying that. 1/2 plus 1 is 3/2. So x to the power of 1/2 times x is x to the power of 3/2. I've then got x to the power of 1/2 times 2, which is 2x to the power of 1/2. Next example, I've got root x plus 3 all squared. So I'm going to rewrite the root x as x to the power of 1/2. And then I'm going to expand these brackets. I'm going to do it the slightly longer way, just to be super clear. X to the power of 1/2 multiplied by x to the power of 1/2. So we're going to add those powers together. 1/2 plus 1/2 is 1. So we get x to the power 1. Next, we've got x to the power of 1/2 times 3, which is 3x to the power of 1/2. Next, 3 times x to the power of 1/2 is 3x to the power of 1/2. And then finally, we've got 3 times 3, which is 9. The x to the power 1, I'll just write that as x. And then I've got 3x to the power of 1/2 plus 3x to the power of 1/2, which is 6x to the power of 1/2. Plus the 9. Next example, I've got root x plus 3 divided by x squared. So I need to divide the root x by x squared and the 3 by x squared. Both of those terms need to be divided by the x squared. Now this root x here, I know I can rewrite that as x to the power of 1/2. And now, to divide these two terms, I'm going to subtract the powers. So 1/2 take away 2 is minus 3/2. The 3 over x squared, I can think of that as being 3 times x to the power minus 2. So 3x to the minus 2. And the last example on this slide, I need to expand those brackets on the numerator, and then I'm going to need to divide each of those terms by the 3 root x. So x plus 1 times x plus 1 will give me x squared plus 2x plus 1. And now each of those terms will need to be divided by 3 root x. In order to help me to do that, I'm going to rewrite the 3 root x as being 3x to the power of 1/2. Remember, the square root means a power of 1/2. And now let's just go along each of these terms then, because we're dividing, which means we're going to subtract the powers. Remember, the numbers, the constant numbers will stay where they are. We're not going to move those. So the first term, the x to the power of 2 divided by the x to the power of a half, take away the powers, 2 take away 1/2 is 3 over 2. And that's 1/3 there, stays there. Next, we've got the x to the power 1 divided by x to the power of a half. So take away those powers. The 1 take away a half is a half. And the 2/3 at the front stay there. And then finally, we've got the 1/3 x to the 1/3 times x to the power of minus 1/2. The x to the power of 1/2 on the denominator there is going to move to the numerator and be a negative 1/2. Last bit for this video is to use index laws to be able to solve equations. You'll remember earlier on in this video I talked about rewriting 25 to the power y as 5 squared to the power y. So we could write it as 5 to the power 2y. That's going to be really useful in these questions because I've got 4 to the power x is equal to 8 to the power x minus 1. And I noticed that both the 4 and the 8 can be written as 2 to the power. 4 is 2 squared, 8 is 2 cubed. So I'm going to swap the 4 to be 2 squared, and I'm going to swap the 8 to be 2 cubed. That's going to give me 2 squared to the power x equals 2 cubed to the power x minus 1. I can write the 2 squared to the power x as 2 to the power 2x by multiplying the 2 and the x together. And then multiplying the 3 and the x minus 1 together, I get 3x minus 3. 3 times the x and 3 times the minus 1. Now, crucially, because the bases are the same, the bases are equal to one another, so that must mean that the powers must also be equal to one another. So 2x must equal 3x minus 3. And you can see now that we've now turned this into a nice simple linear equation to solve, where I can subtract 2x from both sides. And then add the 3 to both sides. So x must be 3. And you could substitute that back in at the beginning if you wanted to. 4 to the power 3 is equal to 8 to the power 3 minus 1. 4 cubed is 64, 8 to the power 3 minus 2, 8 squared is 64. You can see we've got that correct. And the second example, this one looks much more complicated, as you can see, but we're going to do exactly the same thing. We noticed that 9 is the same thing as 3 squared, and 27 is the same thing as 3 cubed. So let's swap the 9 for the 3 squared. We'll swap the 27 for the 3 cubed. Now using index laws, the 3 squared, or to the power b, is 3 to the power 2b. The 3 cubed to the power 4 minus b is 3 to the power 12 minus 3b, because the 3 times the 4 and the 3 times the minus b. So we're looking a bit better now. The left-hand side here is still a little bit complicated, but thankfully I've just got 3 to the power 1 there. The bases are the same, which means I can add these powers together. So I could rewrite this as 3 to the power of 1 plus 2b, or 2b plus 1. Now I've got the bases the same on both sides of this equation, which means that the powers must also be the same. So I know 2b plus 1 is equal to 12 minus 3b. Add 3b to both sides. Subtract the 1 and divide by 5. So b is 11 over 5. Make sure you have got all of your notes copied down onto your homework for this, and hopefully now you're able to answer the rest of the question sheet as part of your homework.